Nightingale initially presented in the Commission report a diagram of figures comparing the overall death rates to the death rate of civilians in the city of Manchester, which, at 12.4 annual deaths per thousand, was considered one of the unhealthiest cities in England. The difference was astonishing. The small black disc in the center shows what would have been the mortality of the Crimean Army had it been as healthy as Manchester, Nightingale told her readers. Now contrast with this the great black bat's wing on the right hand of the diagram. The whole of that black area outside the small innermost circle shows the excess of mortality in the army. This circular chart probably looks unfamiliar unless you've played around with some spreadsheet software and tried out its modern descendant, the radar chart. More typically, we would use a straight XY axis. Here's what that kind of diagram looks like, using the same numbers. The impact is just as great. The line for Manchester is so small compared to the one for the Army that you can barely see it. So why did Nightingale arrange her diagram in circles? It was probably something she learned from her mentor, William Farr. In Farr's study of the 1848 cholera epidemic, he included a set of circular diagrams showing the relationship between temperature and mortality in London over a 12-year span. The circular shape is good for communicating the annual cycle, and if the months are in the same position on every one, you can quickly make year-to-year comparisons for different periods. On the other hand, you need multiple diagrams in order to keep them from looking too crowded, whereas on an XY diagram, you can make each axis as long as you like. The circular shape also makes this kind of diagram harder to draw, especially without the help of computer graphics. But Nightingale wasn't entirely happy with her results. They are open to, and have actually been subjected to, mathematical criticism, she explained in a letter to her sister Parthenope, as the only comparison intended being between the lines, and nevertheless the spaces being shaded to bring out the lines. Ignorant people conceive that the comparison is intended to be between areas, and people who know say, no, it isn't. In other words, the great black bat's wing, as she described the most prominent area of her diagram, means nothing. The line at the outside edge of the shaded area is what is important, not the shaded area itself. Nightingale admitted that it was picturesquely striking, but she wanted to replace it with something more mathematically correct. In her own separate report, she tried something different. They look a little like pie charts, and in fact some Nightingale biographers have mistakenly credited her with inventing the pie chart, but that's not what they are. Pie charts would look like this. See the difference? In a pie chart, the radii of the wedges are all the same, and the width of each wedge depends on the number it represents, so that the areas of the wedges are in proportion to the numbers. In Nightingale's diagram, the reverse is true. The areas are still proportional to the numbers, but the wedges are all the same width. The radius of each wedge depends on the numbers. Nightingale called this technique a polar area diagram. Sidney Herbert called them coxcombs because he thought they looked like the top of a rooster's head.